So here are a few examples on domain and range of functions that are not as intuitive as some of the other ones. So we'll start with domain, and anytime you want to look at the domain of a function, you want to look if there's any restrictions. Domain are the input, your x values. So because we have a square root, the quantity has to be positive, but because we're in a denominator, that denominator cannot equal 0. So our restriction for the square root in the denominator is whatever that quantity is under the denominator has to be non-negative, but it also cannot be 0. So we'll set that quantity greater than 0. And when we do that, we get x minus 4 is greater than 0. Solving this inequality, is going to give us all x values greater than 4. That is going to be the domain for this function. Okay? When you talk about the range, this is sometimes a little harder to algebraically look at. We'll also look at a graph. But the range is going to be the set of all the output values that you could potentially even get from a domain greater than 4. So if we plug in 5, we plug in 6, we plug in 7, the difference between x and 4 will get bigger and bigger. The square root will get bigger and bigger. The denominator with the square root, as I said, will get larger. So 1 over that answer will also get larger. So for this equation, it can't be 0. There's no output that would ever make 1 over the square root of x minus 4 actually equal 0. But every output that we could possibly get will be greater than 0. And that is the range for this question. And to go to a graph and look at this, I'll use Desmos. And I'll go and I'll do y equals 1 over the square root of x minus 4. And you can see this on the graph. Okay, I can zoom out a little bit if you like. The fact that x is greater than 4 is seen with the vertical line that's trying to go up. So all x values greater than 4. But if you want to look at the y-axis, it gets closer and closer to the x-axis, but those values still never quite reach. So for this one, you could say that the range is everything greater than 0. It'll never be 0, but it can get really close to 0 for values that are extremely close to 4, because you'll square root that number and it'll be almost 0. So for this one, the range value is all y's that are greater than or equal to 4. All right, for a separate example, we have a function where it's 1 over 4 minus the square root of 4 minus x squared. The domain finding of this will be similar, the range not so much. So for this one, same thing as before. We have a square root, but we also have it in a denominator. So whatever is under that radical has to be set greater than 0. So if we do 4 minus x squared greater than 0, so this is for domain, then we get that 4 is greater than x squared, or if you'd like to rewrite that orientation, x squared is less than 4. So you're looking for all numbers of x whose square is going to give you a number that's less than 4. So you can square root 4 and you get negative 2 and 2, but you have to know what to do with it. In this case, if we want that square to be less than 4, then our x values are going to fall in between negative 2 and 2. So that's the domain for this problem. All right. Range is a little bit harder to explain. It is not exactly everything greater than 0. You have to look at what potential output values you could get from a domain restriction from negative 2 to 2. You know, the largest number that you can square is going to be really close to 2, and that'll be really close to 4 when you square it, and 4 minus a number really close to 4 is where you're going to be able to get extremely large numbers for your range. But the question is, where does it start? Is it all y values greater than 0, or is it all y values greater than some other number that we're not sure of? So we'll go to the graph in a second, but if you looked in between negative 2 and 2, and you could figure out the lowest point, especially on a graph, that it could be, or even the largest that would be, you know, the largest that the denominator of 4 minus x squared could be is if that x value were 0, and that would give you 1 over the square root of 4 which is 1/2. And if we go to the graph for this function and do 1 over, let me go back, 4 minus x squared, get a little bit of a different graph. It's a concave up shape. It does bounce between -2 and 2 for domain, but if you'll notice the range, I can even zoom in if that helps, but the function doesn't even begin graphing until you get to the y value of 1/2, which is sort of what that 1 over square root of 4 will give you. So the lowest function value on this graph is 1/2. You can see that on the graph, and then if we go back and look at the range, the way that you would express the range is it's every y value that is greater than or equal to 1/2, or if you want to do greater than or equal to 0.5, but it would include that value, and it would be everything greater than that is what you could possibly get. So the range is a little bit harder to explain algebraically. You can sort of think about what the function does, but if all else fails, you can always take a graph on your calculator, look at it, zoom in, trace, look at the table, see what it does, but you should be able to come up with what that range is for the function.